I'd like to thank everyone who joined us today. Welcome to today's CNCF webinar, What's New in Linkerd 28 Multicluster Kubernetes made simple and secured by default. I'm Paul Simões, Solution Engineer and Cloud Native Lead at Oracle and CNCF Ambassador. I'll be moderating today's webinar. We would like to welcome our presenter today, Oliver Gould, Linkerd Product Leader, co-founder and CEO of Beyond.
Thanks, Paul.
Nice to meet you. Sorry.
No.
A few housekeeping items before we get started. During the webinar, we are not able to talk as an attendee. There is a QA box at the bottom of your screen. Please feel free to drop your question there, and we will get to as many as we can at the end. This is an official webinar of CNCF and is subject of CNCF Code of Conduct. Please do not add anything to the chat or questions that will be in violation of the Code of Conduct. Basically, please be respectful of all your fellow participants and presenters. Please also note that the recording and slide will be posted later today in CNCF webinar page. With that, we'll hand it over Oliver to kick off today's presentation. Good luck, Oliver.
Thanks, Paolo. Hi, so as Paolo said, I'm Oliver, and I'm here to talk about Linkerd. In 2.8, which we released almost a month ago now, we introduced new functionality specifically targeted around connecting multiple Kubernetes clusters securely without too much work. And I'm going to start today by going through kind of the quick history of Linkerd and its features, and then I'm going to do a little bit of an exploration of the new feature, multicluster, and a demo of that. Assuming everything works, we'll see. So Linkerd is an open source service mesh. We've been working on it I've been working on it for almost 5 years now. And we donated it to CNCF early in its life in January of 2017. And since then, it's been in production at a number of companies, including some of the big ones you see here, and many more. We've got a very active Slack channel, an active GitHub. Everything is done in the open. We're committed to open governance, unlike some other notable service mesh projects. And we try to have a really kind of rapid iterative cadence to the project. And so we do weekly edge releases, and those allow us to be continually testing and validating new features with people who can do experimentation and staging clusters. And then we do a stable release every 2 or 3 months, and that's usually fit to the features that we're working on. So as I said, we donated Linkerd to the CNCF in 2017, but before that, a lot of the technology we built in Linkerd 1.0 came out of Twitter. And so that was based on the Finagle ecosystem, which is a JVM library for doing microservice communication. And we packaged that up into a proxy and put a control plane on it. And that was Linkerd 1. And we learned a lot from that. And that was a little bit before the Kubernetes era. That was when Mesos was really popular. And so Linkerd 1 was focused on connecting many of these different environments and making service discovery very flexible and reliable across these kind of varied ecosystems. As Kubernetes got more traction, we've realized that the pod model and the need for sidecars really did not suit a JVM-based solution. And so we set out to rewrite Linkerd entirely. Was initially called Conduit, became Linkerd 2.0 in September of 2018. And that's been the kind of main thrust of our development work since. And so we're now on 2.8 and planning 2.9 coming up in a few months. So what does Linkerd do for you when you install it? Right out of the bat, we give you golden metrics. These are how successful is my service? Am I failing requests? How many requests am I doing? What are their latencies? What are their P99 latencies versus their P75 latencies? Furthermore, we can give you topology graphs and all sorts of interesting visibility just by virtue of being in the data plane. And I'll get more into that architecture in a second. We also deal with a variety of connectivity and what you might call reliability concerns. So things like load balancing, retries, timeouts, and now multi-cluster. And the goal here is that you have many pods talking in your infrastructure, and you need to connect them and make sure that if a pod disappears, that's done reliably. And then we focus a lot on security. And so we provide transparent automatic mTLS by default, and we integrate with a lot of the Kubernetes ecosystem. I'll get more into that later. The main focus here is on operational simplicity and really embracing the Kubernetes model to make Linkerd basically an add-on to your Kubernetes cluster that enables all sorts of these good features. And so quickly, for those of you on the chat who may not know what a service mesh is, I'll give you the kind of quickest description I can. And this really kind of falls out of a microservice world. In a microservice world, we have applications that are distributed and small, and they communicate over the network instead of library interfaces. And so we end up with arbitrary topologies of things talking to each other. With the service mesh, what we do is we add a sidecar proxy, and the Linkerd 2 sidecar proxy is designed to be very small and lightweight. The resource utilization is a big focus for us there. And that sits alongside your application, providing a lot of the functionality we just described. And then that's all driven and managed by a control plane. And so our control plane augments the Kubernetes API and control plane so that the proxies can configure themselves and discover automatically and get bootstrapped without you having to configure anything to get started. And that looks something like this. And this is a little bit too detailed of an architecture graph, I think, but it kind of shows the picture, right? So we have a control plane that's mostly implemented in Go, and we chose that so we can be really tight with the cloud native ecosystem. We can use Kubernetes client Go libraries directly. We can embed things like Prometheus clients and Grafana. Like there's lots of things in the open source, in the cloud native ecosystem here that we want to be able to leverage open tracing and telemetry, for instance, in the control plane. All of the communication between the proxy and the control plane is implemented over gRPC, which is API description language and implementation, also CNCF. And then we have implemented a proxy in Rust, and that leverages the Tokyo ecosystem, which is now powering parts of Lambda and parts of Microsoft. The Rust Tokyo ecosystem is really taking off, and it's really powerful. And that's where I spend a lot of my time these days, is working on that proxy. So unlike some other things in this space, Linkerd is designed to give you out-of-the-box functionality. You can almost think of it, I mean, as a widget, right? You have a Kubernetes cluster, and you're not really overlaying that with a service mesh. You're adding some components into your cluster that give you these features. And so we want that to be a very lightweight initialization process. And so we don't require you to configure very much to get started. Of course, you can go deeper and configure more things the more you get out, but that can't be the first step to getting TLS out of the box. Again, because we're in this sidecar model, and that's mostly driven by security concerns, we really focus on a minimal overhead. It can't be a big hefty proxy that installs centrally. This has to be something that's lightweight and just fits in your pod without much overhead. And then we've taken the control plane and really made it Kubernetes native. It deals with Kubernetes primitives and understands these things really well, and the proxy does not, and that's managed via the API. So a basic installation without many replicas. You can scale this up kind of however much you want. We can get the control plane in well under 200 megs. Prometheus, we bundle Prometheus by default right now, which is quite a bit larger, or can be. But there's some work going on right now to make that an optional component. And then the data plane, the proxy is implemented in Rust. That's about 20 megs RSS for most workloads. We see 3 nines latency under 1 millisecond in the basic tests. It can be a bit higher with more load. But the goal there is to be very lightweight and out of your way. And there's a whole bunch of blog posts and talks we've done about this stuff, so definitely go seek it out. How exactly fast or small is it? A year or maybe Yeah, a year ago, we worked with Kinvoke to do some benchmarking. And this is an outside group that's really good with Kubernetes. And we said, okay, build a service mesh harness that you can use to benchmark so that we actually have some baselines about resource consumption and latency and how we compare to Istio especially. And what we saw that Linkerd is really much lighter weight in the majority of cases. I encourage you to go dig into that blog post. The Kinvoke folks do a much better job of explaining it than I do. And I hope that we'll get some updated numbers in the next couple months too. We'll come more here. So what does Linkerd do? Here's the kind of background, but let's go a quick tour through the features. The single sharpest tool we have in our toolkit is a load balancer, right? And so by default, when you use Kubernetes services, it's using IP tables via kube proxy to do service discovery and load balancing. And that's very crude because it's connection oriented. And so what we do in the Linkerd proxy is actually use the latency of requests, of the responses to requests. Because we're at the HTTP level and not just the TCP level, we can actually implement latency-aware load balancing for both gRPC and HTTP out of the box, so no configuration again. And so that's all client side. There's no centralized state. That's all measured in process locally. And it's all implemented off of Kubernetes services and lets you bypass kube proxy. And again, totally transparent. You don't have to change config or code. You just add the proxy and it does load balancing for you if you wanted to. Practically speaking, this actually can have a really big impact in production. And so this chart here shows us that the load balancing algorithms we choose can actually substantially improve reliability. And so if we see that with a simple round robin load balancer, and we have a timeout at 1 second, we have about 95% success rate. And just by changing the load balancing algorithm, we can push that up over to 3 nines, which in many on-call rotations is the difference between waking up and sleeping through the night. So these simple techniques can actually add a lot of reliability improvements into your infrastructure. My favorite Linkerd feature is the fact that we do automatic transparent mTLS. And so this is kind of decoupled from your application, but anytime you're doing HTTP between pods that have the proxy, we can discover that and we can automatically establish mTLS between these pods. And so by virtue of adding a proxy, you get required mTLS for your HTTP traffic, as long as it's coming from another pod with proxy traffic. We're working on more policy on that side, but I'll get to that later. This is all bootstrap off of Kubernetes primitives, so we're not adding any new CRDs to do this or anything like that. We use the service accounts that are already embedded in your pods to authenticate to the Kubernetes API. We use that to validate your certificates. These get rotated automatically by default once a day, but those could be turned up quite a bit more if you're eager for that sort of thing. The key material for these certificates never leaves the pod, so they're totally ephemeral, applying the zero trust model. And it works really well with things like Cert Manager. And so we've done a bunch of integration work over the last few months to make Cert Manager be able to manage the signing certs that are used by the control plane. And to put a very clear point on this, this is not does not conflict with anything you're doing with TLS today. So if you already have TLS in your application, Linkerd will just treat it like arbitrary TCP and forward it without doing anything to those connections. And then if you don't and you have the proxy, we'll automatically do this for you. And right now, I said earlier that this only works with HTTP, but the thrust of the work we're doing at the moment is to broaden this for arbitrary protocols, so RabbitMQ or Memcache, whatever, really. And again, no application changes. You don't need to change your code, your pod specs, or any of that to get this functionality. You just really add an annotation once Linkerd is installed and this gets all set up. One of the other kind of less talked about features in Linkerd is that between pods, in the mesh, we do everything over HTTP2. So any HTTP traffic within the pod actually gets transported between nodes over HTTP2. This lets us amortize connection costs, right? So the big downside to applying mTLS is that we have this extra handshake work that we have to do as connections get set up. And so with Linkerd, what we do is we pay that cost as infrequently as possible, and then just send all of the traffic between these well-established connections that get torn down lazily. And that all happens without your application having to know anything. We take HTTP1, we turn it into HTTP2, and then we turn it back into HTTP1 for your application. We also support a newer feature called traffic splitting. And this is something we've worked on with the SMI, the Service Mesh Interface, which is a CNCF project that's a really group of different service mesh implementers and consumers. And traffic split allows you to implement things like blue-green deployments via Flagger, and I'll have a little bit of a demo that shows this later, so I won't talk about it too much now. But SMI does cover a bit more, and we're still working with that group to define probably a next version of the policy API. We already support their metrics API, and there's more work going on there. But this is a great place if you're interested in service mesh generally to come and see what kind of the biggest API pieces are that we want to standardize on and don't want to have be coupled to any one service mesh implementation. So what this really allows folks to do is someone like Flagger can go implement traffic shifting, and it's not coupled to Istio or Linkerd or any of the others. It's just they implement traffic split via these resources, and Linkerd and the others know how to consume them. And it's a really a blessing for the community, I think, to have this. As I said earlier, we bundle Prometheus with Linkerd today. And that's so we can give you out-of-the-box stats. And so as soon as you install Linkerd, you can get Grafana dashboards and you can get metrics immediately. And we have this really hydrated Kubernetes Prometheus data, which is informed by the Kubernetes API. And so we can take labels and metadata from the Kubernetes API and make sure the proxies annotated that. So when we know a request rate, we can say a request rate to this namespace on this service. And that's all kind of informed from the control plane. And it can be extended to support, you can use OpenAPI or gRPC specs to get kind of really detailed per route metadata and configuration. And again, no application changes, just by installing Linkerd, you'll get a whole bunch of visibility there. We also support open census tracing. And there are application changes required to do tracing. Your application has to be configured to participate in tracing for it to be a valuable feature. And so this isn't something we really spend a lot of time talking about, but it does work, and it's great for, especially for when you're debugging how the proxy impacts your infrastructure. You want to see all the hops that the proxy is doing and how much latency is spent there. We also have a brand of no application change tracing called Linkerd Tap. And this is kind of what we call ad hoc tracing, where at runtime, you can actually connect to proxies if you're authenticated, that requires RBAC, et cetera, and see a stream of metrics come, see a stream of requests come out of the proxy in real time. And so this gives you things like tracing without having to do all of this application change or prior to deployment setup. Great, and that brings us to what I really wanted to talk about today, zero trust multicluster. And so this is the newest feature that we've been working on in Linkerd, and we're working on a set of enhancements that will be in 2.9 for this as well. And the multicluster work, we wanted this again to be to fit into the Kubernetes model, into the existing Linkerd ecosystem, and not be a new set of CRDs to go manage or a new set of abstractions to go learn. So this is backed by Kubernetes services, and the traffic split I just talked about makes it much better. I'll show you how. It basically allows it to be transparent to the application, which cluster you're talking to. This is all secured by mTLS, so we don't allow you to do multi-cluster without Linkerd's mTLS, and that's by security, it gives you kind of explicit trust relationships between your clusters. And this is totally optional, so a default Linkerd install will not include it, but it's an easy add-on after the fact. And again, no application changes. We just kind of make this work automatically. And this works through two components. And the interesting part of this is the service mirror. And the service mirror is a controller that sits in your Kubernetes cluster and watches another Kubernetes cluster. And as services are created in that cluster, it imports those references to those services in the local cluster. And so if I'm in the west cluster and I'm watching the east cluster and a service foo gets created, I'll create a service foo east in my cluster, which gives me a handle to start talking to that other cluster. And what that actually does is point traffic from that service to a remote gateway. And so that service does not front any pods in the local cluster. The service fronts a target in the remote cluster. That gateway terminates mTLS and then routes into the cluster. And so we get secure communication on the edge between clusters. And then everything in the cluster works just as it would normally with local services, and there's no real special thing to set up from that point of view. And this allows us to even, if you want to get really custom here, you could break this down into really small R-backed service mirrors that only can control one namespace or some set of namespaces. And so again, this is made to fit into the Kubernetes model and just lay in with the existing RBAC and service accounts and everything else you're doing to secure the cluster. It can't be a secondary thing that you have to go do. And I'm going to try to give a little demo of this, assuming that my computer is working properly. So let's see what's going on here. If there are problems with the video, I'm sure someone will tell me. Okay, and so what we've done here is, let's first see. I'm gonna just, we look at the command here. I have two clusters using K3D, which is just a nice way to run a Kubernetes, several Kubernetes clusters locally on my laptop without it overheating. And so I have an east cluster and a west cluster, and they're both running locally for now, just for the sake of demo. And I've installed Linkerd into them already, so we don't have to wait for the clusters to come up, but it took about 2 minutes to get this set up. I have a script that does it if anyone wants to see it. It's linked in the slides that we'll share later. Great, and so now I want to deploy a demo application and see how Linkerd deals with routing communication between these things. Okay, so first things first, let's create our demo app. So I have some customized configs here, one for the east and one for the west, and we'll just deploy those. Again, all these configs are up on GitHub for you to play with yourself. Great, and so that was easy. We'll take a quick poke at this, but we now see that we have emoji Bodo deployments in each namespace. They're starting up, and there's nothing to do with multicluster yet. We've just got these things running, and we'll take a quick, no traffic yet, waiting for them to come up still. Kubernetes. I'll quickly show you how this is laid out here. So I'm using customize with our emoji Bodo demo app. And I've configured this to inject Linkerd into these deployments. And so that's these little patches I've done there. And then in the east and west cluster, let's start with the east. We have a traffic split, and that traffic split is really there so that we can have a logical target that's split, that's split between these things. And so in this case, I know we're going to create a west mirror, and I've weighted it to 0, and everything is going to the default cluster. Okay, let's see if we get stats yet. Great, now we see the services. And we see they're getting traffic. And so we have some sample application that's just generating some load on these clusters now. And so the cluster set up, they can't talk to each other, even though we have the multi-cluster component set up. Next, what I want to do is link these clusters. And here's a little bit of a hack I had to do just for K3D. You won't have to do, you can use the normal Linkerd commands in your own cluster. And again, all these things just generate YAML. So if we look at what a multi-cluster link does, it generates a kube config. And so what this does is it connects to the east cluster, gets a kube config so that we can talk to its API, and then we apply it to the west cluster. And so I'll just do that now. And now we've created credentials so that the service mirrors in either cluster can read from the other clusters. And immediately, we'll see these clusters get new services. So now in East, we have these services that are called West. And in West, we have services suffixed by East. But no traffic is going to them yet, or we haven't configured them to be used. And so what I'm going to do next is update the traffic split. So we'll update the East split to send some of the emoji traffic to the West cluster. And let's say we'll do 80% to the local cluster and 20% to the other cluster. And I'll just apply that again. Okay, so we've reconfigured just that one traffic split and haven't changed anything else. And now we see that the West cluster is getting some traffic. And it's getting about 20% of the traffic. If we go update that further, we can fail all of the traffic over to the West cluster. And now we'll slowly see that traffic bring. It'll take some time for the metrics to upgrade because these are windowed. And so, yeah, we slowly see that RPS number, which is averaged, move over to the new cluster. This is all done again with TLS. We can tap things. And so tap is that I was showing you before. And now if we want to look at the East cluster and see where web service is sending data, well, we can actually go see here in one of these outputs that we're sending to the Linkerd gateway in the other cluster. And it's enabled with TLS, and we've got the identity system all set up from there. And so hopefully that conveys how simple we intend this to be. I know it's not the flashiest demo, seeing me type in the terminal. So before we get to a Q&A, and I want to spend as much time we can for you on that, I just look forward a little bit to what's coming out in the Linkerd community. And so right now we're focused on kind of these two big pillars. One is splitting up the control plane. And so we saw that architecture diagram earlier with a bunch of components. There are only 3 of those components that are actually needed to run Linkerd in production. And so we want to really strip that down to be the mTLS identity service, the service discovery for load balancing, and the proxy injector, which is a webhook that adds the proxy to your pods as they're initialized. And so we're doing work to make Prometheus configurable, so you can either use your own Prometheus, or if you don't want any of the web interfaces at all, you can just leave that component out. And so that's work that we're doing in 2.9 and probably into 2.10, because there's quite a bit of work to set that up to be the way we want it to be. The other thing we're working towards is mandatory TLS by default. And the real wrinkle there is in Kubernetes health checks and things that we can't mesh. But other than that, the big requirements are that we get all TCP traffic into the mTLS system. So we're working on supporting arbitrary TCP protocols, as I mentioned. That's also going to mean that we're going to start introducing TCP load balancing into the proxy. So again, bypassing kuproxy for service IPs. And we're also starting to do a little investigation into proxy WASM. And if you're not familiar with that, proxy WASM is an ABI that allows plugins to be written for proxies like Envoy. And there's really no reason why we can't support the same interface in our proxy, so that if you have plugins that do header rewriting or authentication or whatever, you should be able to plug that in the Linkerd the same way. And that's a pretty big change, so we're just starting to investigate that. But one of the ones I'm more excited about. Should also call out that we're going to be heavily present at the virtual KubeCon, Cloud Native Con in August. There's plenty of talks by Linkerd developers and Linkerd users. I definitely encourage you to come and be involved, part of the community for that. It's usually fun, but we'll see how it is in the virtual world. It'll be new to all of us. And I also want to call out that, again, we are like heavily committed to Linkerd being an open governance project, where it's not just the people at Buoyant doing the work on Linkerd. So we've opened up maintainers. Nordstrom, for instance, has a maintainer that helps us with maintain the CNI. And we're looking for people who want to get involved in the project at various levels. And so you don't have to be a core maintainer to get involved in the project. It might be enough to help people in Slack or on GitHub, or get involved and help us prioritize and plan what features you think are really important. So anyway, if that's appealing to you, please do get in touch. Either email me, ver@buoyant.io. We have a Slack that's super active. We do monthly community calls. We have an RFC process. So if you think you know what you want to change, you can go start there. And we've also, I should call out that we've done 2 security audits now, one of Linkerd and one of some of the underlying TLS infrastructure. And with that, I think we're ready for questions.
Oh, awesome. Oliver, really thanks for your presentation. Great presentation today. We now have some time for questions. If someone has a question that you would like to ask, please drop it in QA tab at the bottom of your screen. We have 16 questions now, Oliver. The first one, can Linkerd be used with Docker Swarm, or is Kubernetes a harder requirement?
That's a good question. So today Kubernetes is a hard requirement, especially for the control plane. The proxy itself has no dependencies on Kubernetes, but for instance, to do mTLS with automatic identity, we need to bootstrap that off of something like the Kubernetes token system. And so I think if other folks wanted to get involved in writing another control plane or porting some of our control plane components to other infrastructures, that could work, but it's not there today. I would certainly support that if someone in the community wanted to help there.
Okay. George Gonzalez asked, is there any news on the mTLS and non-HTTP service custom TCP protocol connection?
Yeah, this is a very sought after feature, and we're hard at work on it. It's planned for 2.9. We'll have it in Edge before then. This project, honestly, the scope increased a little bit. And so where we started of just, it's going to be very simple, we realized that we really want to do this with 4 service peaks first protocols as well, for arbitrary TCP protocols. And so the ordering of deliveries changed a little bit, but it will definitely be in 2.9, and that's definitely a top priority for us. So stay tuned and watch the Edge release notes, because it'll drop in a couple weeks probably.
Nissan Ula asked, please clarify, when services are in the mesh, Kubernetes services are not the mechanism used to load balance requests. The proxy takes over load balance. Does it work in conjunction with Kubernetes service?
Good question. So Kubernetes services, what they really do is select over pods, or really provide you a set of IP port endpoints. And so there's endpoints and endpoint slices, which are what feed those. We use those APIs, the Kubernetes service and endpoint slices APIs, to feed the load balancer. And so we're using Kubernetes objects and all of that data to populate the load balancer. This is similar to the way that kubeproxy uses this metadata to implement its load balancer. And so we're both using Kubernetes services to inform different load balancers.
Jorge Gonzalez has another great question. Is there anything similar to Kiali for Linkerd, or is the observability mesh graph from the dashboard have been improved?
That's a good question. Well, one, we'd love help improving the dashboard if you have ideas on that. Two, we've been talking to the Kiali folks, and especially the SMI team has been talking to the Kiali folks about modifying the SMI telemetry API to for Kiali's use so that Kiali will work with any service mesh. I would really like to see that happen, but I don't have the latest state of that. So I'm going to direct you to the SMI organization because they'll probably know more.
Well, Alankar asked for a product with around 20-25 services, this is Linkerd an overkill?
So my answer is no. I mean, but it depends on what problems you're trying to solve, right? And so the value you save is the code you don't write. And so if you already have mTLS working, and you already have visibility, and you already have the things that you want at a Linkerd, then yeah, it's probably overkill because you don't have to write any code. If any of those things are things you want, then Linkerd is probably the lightest way to get them. Certainly the least amount of work on your part. I would make a plug there that I think mTLS belongs in every cluster. I actually don't think there are production applications that should not be using TLS. Those are pretty rare, and I'm skeptical that they even exist.
How is service discovery done between different clusters?
Great. So the way this works is that you have a gateway service on either cluster, and I can actually probably just show you this right here. So if we get So what we see here is that we have a gateway service in each cluster. And we connect to the other gateways, and we re-reference those two here, right? So in the east cluster, its gateway is this, and it has a reference to the west cluster, which is that IP. When we create services, when we create these mirrored services, so when we create the emoji west service, let's see if I can pull it up. So in this emoji west service here, that actually points to the gateway, to this gateway. And so we populate the endpoints in that service to talk to the remote gateway. We know the identity of the remote gateway, so we can do mTLS to it. And as long as both clusters have common trust roots or are able to trust each other via TLS, everything will just work. So the next question from Jindong is, I'm learning Kubernetes. Is it possible to explain a bit between control plane and data plane? So when we talk about control plane and data plane, what we mean is the control plane is a set of APIs that you interact with to configure things and to discover things. And we want that to be very decoupled from the data plane, which is where requests and services are actually transporting, right? And so you don't want to, you want a kind of dumb data plane that's just really good at forwarding things and you're not interacting that with directly. So control, you could think of as API, Kubernetes API. Data plane is the actual kubelet and the pods and the traffic flowing between them.
Is the service mirror?
Yeah.
Oh, sorry.
Go ahead. Go ahead.
The next one is the service mirror case. How is the latency?
I mean, the latency is whatever your latency is between clusters, right? So we're adding a hop, which is some latency. And so there's probably a couple of milliseconds latency just from going through the gateway. And I guess about 1 to 2 milliseconds in most cases. And then and then everything else is going to be the latency of the link. And so we're talking to some folks who have interesting ideas around how to do load balancing in a topology aware way. And there's a service topology system coming to Kubernetes that's in alpha or beta right now. And so there's work about being latency aware in that case too, but it's new.
The next one is, what are advantages of Linkerd data planning versus Envoy?
That's a common but good question. So when we started on this, the ecosystem was a little different. And we knew that Rust was a big bet for us looking forward in the future, having the memory safety and the kind of better ecosystem, having been bitten by Heartbleed and a bunch of other bugs in C-based systems over the past couple of years. Rust was really appealing. And two, we don't want a very generalized proxy. And so Envoy is great for configuring it to do all sorts of things. But if you look at a bunch of the issues that Istio's faced, a lot of their complexity and their challenges they've been trying to overcome have been about integrating Istio's use cases into Envoy, which is very generalized and opinionated in another way. And so they've had to go put a lot of the Istio control plane features actually embedded into Envoy in their newest versions. And so our approach has been that we want a very narrow purpose-fit tool that works really well for our use case and that we can modify directly to fit the service mesh use cases. And so our goal is to be tailored and more efficient and more secure. But we also integrate with lots of Envoy-based ingresses, and we're friendly with the Envoy project. We just didn't think it was the right choice to be the data plane for our service mesh.
Oh, the next one. Will the demo be made available on GitHub with a walkthrough, the commands you are running to try this out?
Yes, I will. There's a better demo than the one I just gave that's already on linkerd.io, and I would encourage you to go through that one because someone spent a lot more time making that a well-written thing than I probably will. But the scripts that I've written at least I can share on GitHub and are linked from the slides, so you'll be able to get them later. And Nassim, I can just send them to you afterwards.
The next one, perfect sharing. The Linkerd G2 performance is awesome. Is there any use case that Linkerd can be used in edge layer? Is there a plan to support HTTP3 or QUIC in load balancer or other protocol like the RSocket?
It's a good question. So Linkerd's gateway implementation is actually already kind of an edge feature, right? Where we expect that to be fronting, exposed on the internet, and we take care to make sure that we're ingressing that properly. We have shied away from providing a totally generalized ingress functionality, which is what I see more as kind of the edge layer, because there's a lot of different ingresses already out there that people really like, and the advantages of embedding that directly in the service mesh are not obvious to me. On HTTP3 and QUIC in particular, we actually just had an issue opened up, and I'm really interested in this idea, but there are a number of challenges specifically around the TLS and security model that QUIC assumes that I think don't play well, especially with an in-cluster mesh. But our goal is to not break you if you are using those things. So if you have an ingress that supports QUIC, Linkerd won't interfere with that. And then we'll deal with the mTLS within your cluster at least. Things like RSocket, again, we won't impede these things. We'll transport them like anything else, but we probably won't add a lot of metrics on top of them at the moment. Again, however, if any one of these protocols is near and dear to your heart, it's an open source project. We can help you integrate with the proxy to get the features you want for these things. But we should probably start a conversation about that. But our priorities within the project are more focused on really getting a lockdown, policy-oriented TLS story within the cluster and between clusters.
Can you spend some words on how identity is federated between the clusters?
Great. So the identity systems are actually independent in the clusters, but when you install the control plane, you provide it with a set of signing credentials, signing certificates and keys. My recommendation is to have an offline CA, so a root key that you own and is in a bank vault or something, that you use to issue these signing certificates once a month or once a year to the clusters so that they're able to sign certificates. Then as long as the clusters have each other, either have a common trust root or have a bundle including each other's trust roots, you can establish identity and through that system. If you look through the scripts that I shared earlier, when I create this cluster, we actually create a CA locally, and then we add that to each. As we install the cluster, we use a per cluster signing cert. There are a number of other ways you can go about this, and we're even looking at potentially plugging in with external PKI providers. So if that's something that's interesting to you, please get involved.
To have some reference architectures for HA and DR scenarios?
That's a good question. So we do have a kind of default HA installation setup that what we call, like if you do linkerd install --HA, it adds a bunch of replicas and is within a cluster made to be more highly available than a default install. As you're dealing with multi-cluster HA and disaster recovery, things like traffic split are an important tool in the box, but I don't think we have a total end-to-end reference architecture yet. I know we've had some conversations with people who are interested in that. So I think that'd be a great place to get involved. If I would probably start a discussion on Linkerd's GitHub, and we can see where that goes.
Is there a notion of authorization such as limiting which servers are allowed to talk to a service?
Authorization is not there today. That's something we've been trying to get some of these big pieces like multi-cluster layered in so that we have a model that fits well. And we haven't made any decisions that kind of make authorization or make these other features harder because of authorization. That said, once we've gotten TCP for mTLS nailed down in 2.9, authorization is kind of the big thing we want to target for 2.10 after that. But probably a subset. So the subset is mandatory TLS, which means that we at least have to be able to start authorizing non-TLS clients like health checks and readiness probes and things like that. So that's an active area of design. It's probably, you won't see much of that in 2.9, but getting into 2.10, we'll start to have more of that stuff.
Is there a comparison like the one you mentioned and showed, but the latest Linkerd ES2 versions? A lot has changed in both.
Well, one, the service mesh benchmark tool that can invoke work is open source, so other folks can run it. I have not. Two, I hope to have a more recent comparison soon, but I don't have it at the moment.
Is the demo using Linkerd 2 or 3?
What's that?
Is there a demo using Linkerd 2 or 3?
Is there a demo using Linkerd 2? What's the last part of that?
Yeah. No, not the last part. But the question is if there is a demo with using the both versions, one of the both.
Okay, yeah. So yeah, I know there are folks like Superglue, for instance, that have ways to demo both pretty easily. Again, the service benchmark, the service mesh benchmark project, and Meshery, there are a few projects that deal with these kind of comparisons, and I would defer to those if you want good comparative analyses. But I also hope that we'll have some better internal benchmarks soon. I don't want to commit to a time, but soon.
Do you support root certificate rotation for certification using for mTLS?
That's complicated. It's a little hard. Yes, we do support it, but there's a whole bunch of difficult caveats that you need to consider before you start to rely on that functionality. So Yeah, like the answer is yes with asterisks. So I would get involved in the GitHub and ask more questions about those asterisks.
Sofian said, I don't see the way to plug search manager to Linkerd in the documentation. We can use two questions. Really, the first one is about how to plug certification manager into Linkerd. The second question is if it's possible to use Jagger with Linkerd for multicluster tracing.
Okay, great. So I would say on the first side, Cert Manager is definitely supported. I believe we have docs up on the website, but if we don't, please open a GitHub issue because we should. The second question was on Jaeger. Our recommendation is generally that we think clusters themselves should be basically isolated failure domains. So we don't really encourage you to have a Prometheus instance that spans multiple clusters or a Jaeger instance that does. Or if you do, you should at least have instances within the clusters as well. All that said, what we do is we just send traces to the open census collector. And so however you configure your open census collector, you can certainly implement a federated tracing system if that's something that appeals to you. But it's not something that Linkerd provides out of the box. That's more on the open tracing or open telemetry side of things.
Is there any, we have more 5 minutes and more 6 questions. Let's try. Is there any level of automation with the multi-cluster setup? As in, can I configure a failover with Linkerd? It's
automatable. There's nothing out of the box yet, but that's certainly something that anyone could build on top of this. So it doesn't have to be built in Linkerd directly, right? And so the way I would build that is I would write a Kubernetes operator of some sort that is watching metrics and managing traffic splits based on those metrics. If someone wanted to build that, I'd be more than happy to go give them a ton of advice on how that might work. But it's not something that belongs in the core Linkerd thing, is my assumption.
Can you manipulate the HTTP headers for incoming and outgoing requests, like add, remove, modify headers?
Yeah, we don't offer any of that at the moment. There's some performance costs associated with those sorts of features that we've been reticent to take on. However, I did call out the proxy WASM plugin infrastructure, and I think that's really how we'd like folks to take on that sort of request modification or response modification, is not having to expose it as configuration in the project, but rather giving you the ability to go write plugins that do those things for yourself.
What is done to address potential bottlenecks at the gateways when a lot of traffic is forwarded?
I mean, you're welcome to split up multiple gateways if you need to, and so I think that's a good question about how to test this before to go to production. And I would encourage you, if you have a very high load system, to go to have multiple gateways, and so they can be balanced. But there are there's not a silver bullet answer for that. So testing and provisioning. The
last 3, which proxies is used as sidecar?
So Linkerd uses its own proxy. It's the Linkerd 2 proxy. It's on GitHub. It's written in Rust. It's wonderful, and I love it.
Yeah. How does traffic split work with service load balancer?
So the traffic splitting today happens before the load balancer is played at all. So traffic split really just tells you, try to send it to this service or try to send it to that service with this ratio. And we don't do any balancing between those things. However, I did mention earlier the new service topology features that are coming into Kubernetes core may give us some new abstractions to start dealing with load balancing across these things in a different way, but that doesn't exist today.
The later one, do you support running container pods on Windows? If not, Is it on the roadmap?
Yes, it's on the roadmap. It's not something, we've been talking to the Microsoft team in the past about this, and I believe that they've been doing work towards this, but there's a bunch of things that have to happen in the Windows Kubernetes implementations that block this, and that's not really a Linkerd feature. I think one of the biggest ones is that Linkerd today is configured via IP tables. There's a proxy init or a CNI that is responsible for sending all the traffic through the proxy. And the analogs for that Windows are, I don't know what they are. And so we really want the Microsoft folks to provide some kind of those base pieces for us, and then it'll be easier for us to support. In the implementations themselves, there's no reason why we can't necessarily run any of the components in the build. It just hasn't happened yet.
Okay, all right. That's all the questions we have for today. Thanks, Oliver. It was an amazing presentation. Thank you so much. We learned a lot. Thank you for joining us today. The webinar recording and slides will be online later today. We are looking forward to see you at the future CNCF webinar in QCon online. Have a great day. Thank you, Oliver. Thank you, everyone.
Thank you.